In 1966, a Dutch soil scientist named Wim Sombra walked through the Amazon rainforest and found something that should not exist. Black soil 6 feet deep, fertile enough to grow crops continuously for 2,000 years in one of the most nutrient-poor soils on Earth. Amazon rainforest looks lush because all the nutrients are locked in the living trees. The soil underneath is toxic red clay. When you clear the forest, you remove that living nutrient bank, leaving only infertile dirt that becomes barren after just 2 harvests. Rain washes away what little nutrition exists, and modern farmers abandon fields after a single season. But scattered across the basin, Sombra discovered patches of coal-black earth containing 3 times more organic matter, 70 times more charcoal, and 18 times more carbon than surrounding soil. Soil that had been feeding people since before the Roman Empire. The discovery should have revolutionized agriculture. A technique to create permanent fertility from waste materials. A solution to soil depletion that could feed billions. Instead, it was buried. Not by accident, but by design. Because what Sombok found threatened a $27 billion industry built on a simple premise. Farmers must buy fertilizer every single year to survive. This is the story of Terra Preta, the black earth indigenous Amazonians created from charcoal and scraps. The fertility system that lasts centuries, not seasons, and the agricultural corporations that made certain you never learn to make it. The archive opens with a mystery that baffled archaeologists for decades. Before European contact, between 6 and 10 million people lived in the Amazon basin. Not scattered hunter-gatherers, but organized societies with towns, trade routes, and advanced agriculture. They faced a geological impossibility. The tropical soil beneath the rainforest canopy contains almost no nutrients. Everything valuable exists in the trees themselves. When you clear land and burn it, you get 2 good harvests, then nothing. Yet, archaeological evidence shows these societies thrived for thousands of years in the same locations. The answer appeared in their soil. Terra de India, dark earth of the Indians. Radiocarbon dating reveals these soils were created over thousands of years from 7,000 years ago to just 500 years before European contact. The technique spread across the Amazon basin covering an estimated 150,000 km. Some sites feature black earth 6.5 feet deep. The method was deceptively simple. Indigenous farmers collected charcoal from low-temperature fires. They mixed it with broken pottery, fish bones, animal waste, and food scraps. Then they worked this combination into the earth around their settlements. The pottery shards provided structure. The bones provided calcium and phosphorus. The organic waste fed soil microbes, but the charcoal was the key. Unlike regular compost that decomposes in months, charcoal remains stable for millennia. Its porous structure creates a high-rise apartment for beneficial bacteria and fungi. Its electrical charge binds nutrients like a magnet, preventing them from washing away in tropical rains. Analysis reveals phosphorus levels 200 to 400 milligrams per kilogram of soil, 20 times higher than adjacent areas. Calcium, magnesium, zinc, and nitrogen all test at levels unheard of in Amazonian soil, and it is self-renewing. When microbes colonize the charcoal's pores, they multiply and die, adding fresh organic matter continuously. Terrapter plots actually expand over time. Farmers in Brazil still seek out these black earth patches because they are the most productive land in the region. For thousands of years, this knowledge sustained millions of people in an environment where modern agriculture fails after 2 seasons. Then Europeans arrived. Spanish explorer Francisco de Orellana traversed the Amazon in 1542. He reported densely populated regions, extending hundreds of kilometers along the river, cities, agricultural fields, populations exceeding even those of today. Within 150 years, over 90% of that population was dead from smallpox, measles, and warfare. The survivors scattered into the rainforest interior. The knowledge of Terra Preta creation went with them. The technique that fed millions for millennia disappeared within a single generation. For 3 centuries, the Portuguese portion of the basin sat untouched. The black earth patches remained, still fertile, still producing, but no one knew how they were made. European soil scientists saw the dark patches and assumed they were natural formations, unusual volcanic deposits. Perhaps the idea that indigenous people intentionally created superior soil seemed impossible to colonial minds that viewed native populations as primitive. The Terra Pria sites were catalogued as geological curiosities, nothing more. Until Wim Sombra published Amazon Soils in 1966. He documented the Black Earth's exceptional fertility and its widespread distribution. He proposed what was then a revolutionary idea. These soils were human-made. The archaeological evidence supported him. Every Terra Pria site contained pottery fragments, stone tools, and remains of human habitation. The charcoal was not from forest fires. It came from controlled low-temperature burns designed to create char, not ash. Sombra became known as the godfather of terroir in scientific circles. Before his death in 2003, he challenged soil scientists with one question. If pre-Columbian peoples could do it, why can't we? The answer came from Johannes Lehmann at Cornell University in the early 2000s. Lehmann cracked the chemistry that made Terra Pria work. The key was biochar, charcoal produced specifically for soil amendment through a process called pyrolysis. When you burn organic material in the absence of oxygen at 450 to 500 C, something remarkable happens. You do not get ash. You get a carbon structure with 9,000 square ft of surface area in a single gram. That is nearly the size of 2 basketball courts compressed into something smaller than a sugar cube. This massive surface area holds water like a sponge, releasing it slowly to plant roots. It binds nitrogen, phosphorus, and potassium, preventing nutrient leaching. It houses billions of beneficial soil microbes in its porous structure, and it sequesters carbon for thousands of years. Laboratory analysis revealed Terra Pria contains carbon that is over 2,000 years old. Still stable, still improving soil fertility. The term biochar was officially adopted at an international conference in Birmingham, England in 2009. Research exploded. Field trials across 6 continents validated what indigenous Amazonians knew millennia ago. 4-year trials in the Philippines and Thailand showed 16 to 35% yield increases for rice. Field studies in Ghana demonstrated 30% improvements in maize production. Mediterranean durum wheat yields jumped 30% with biochar application. Meta-analyses of over 400 field trials confirmed an average 16% long-term yield increase. Some crops showed improvements up to 48% when biochar was combined with organic fertilizers. The science was undeniable. Biochar could transform agriculture. So why doesn't every farmer use it? The answer lies in the bank accounts of 5 companies. In 2024, the global fertilizer market generated $27 billion. Nutrien, Yara International, Mosaic CF Industries, and ICL Group control over half of that market. Their business model is elegantly simple. Soil loses nutrients with every harvest. Farmers must replace those nutrients annually. Synthetic fertilizers provide nitrogen, phosphorus, and potassium in concentrated fast-acting forms. And they are expensive. The average American farmer spends $200 to $500 per acre on fertilizer every single year. For a 1,000-acre operation, that is $200,000 to $500,000 annually forever. The fertilizer industry depends on that subscription. Now look at biochar. It reduces nitrogen fertilizer requirements by 15 to 25%. It prevents phosphorus leaching, meaning farmers need less supplemental phosphorus. It improves water retention by 10 to 30%, reducing irrigation costs, and it lasts for centuries. One application of biochar continues improving soil for 100 to 2,000 years. You apply it once, maybe refresh every few decades, but you never need to buy it annually. The math is devastating for the industry. A farmer spending $300 per acre annually on fertilizer invests $30,000 over a century. Biochar costs $90 to $400 per ton for commercial product. Even at premium prices, a single application costs less than 2 years of synthetic fertilizer. Or you make it yourself from waste for free. That is the real threat. Biochar can be produced from agricultural waste, corn stalks, wheat stubble, tree prunings, rice husks, manure, the very materials farmers currently burn or send to landfills. Instead of buying fertility, farmers could create it from waste. No patents, no annual purchases, no dependence on corporations. For these companies, this is not a product. It is a system failure. The fertilizer industry faced a choice. Adapt or suppress. They chose suppression not through outright bans, through strategic silence. Agricultural extension services, largely funded by fertilizer companies, do not mention biochar. Land-grant universities dependent on Agris grants conduct limited biochar research. The USDA has published some studies, but you will not find extension agents teaching farmers how to make biochar. Farming magazines funded by Fertilizer advertising feature articles on the latest NPK blends, controlled release formulations, and precision application technology. You will find almost nothing about biochar. The global biochar market in 2024 generated $541 million, growing at 13 to 17% annually. That sounds impressive until you realize it represents 0.2% of the fertilizer market. 0.2% for a technology that could replace synthetic fertilizers entirely. The suppression is not dramatic. It is bureaucratic. A technique that could revolutionize agriculture simply is not taught. Universities do not include it in agronomy curricula. Extension services do not demonstrate it at field days. Equipment manufacturers do not build commercial-scale biochar production units, and farmers who have never heard of something cannot use it. But the knowledge exists. The science is published. The technique is ancient. You just need to know where to look. Making biochar does not require industrial equipment. Indigenous Amazonians did it with fire pits and patience. You can do it in your backyard with materials you probably already have. The goal is pyrolysis, heating organic material to 450 to 500 C in the absence of oxygen. This causes the wood to char rather than burn to ash. The simplest method is the cone pit. It is free and requires only a shovel. Dig a cone-shaped pit in bare ground about 3 feet across at the surface and 2 feet deep. Start a small fire at the bottom using dry twigs and kindling. Once the fire is established, add slightly larger pieces of wood. When those pieces develop a layer of white ash on their black surface, add the next layer of wood. Continue layering as the fire grows. The cone shape creates a flame cap at the top that consumes oxygen before it reaches the lower layers. This creates oxygen-poor conditions below, causing pyrolysis instead of complete combustion. When you reach the rim of the pit and the top layer shows white ash over black char, quench everything with water. Not a sprinkle, drown it. You need to stop the combustion instantly. What remains is biochar. Let it dry, then crush it into smaller pieces. Bag it and crush it with your feet, or pound it in a bucket with a piece of wood. The goal is particles that pass through a soil sieve, but do not put it in the soil yet. Remember, biochar is a sponge. If you put it in fresh, it will suck up the nutrients from your soil. You need to charge it first. Soak it in compost tea, worm castings, liquid kelp, fish emulsion, or even diluted urine for 24 to 48 hours. Fill those microscopic pores with life. The biochar absorbs these nutrients, then slowly releases them when applied to soil. Then mix it into your garden. You only need to do this once. Research shows benefits at application rates as low as half a ton to 2 tons per hectare each year. You do not need to bury your garden in char. A handful mixed into planting holes begins improving soil immediately. For larger operations, 10 tons per hectare provides dramatic improvements, especially in poor or degraded soil. That charcoal will remain in your soil, housing microbes and holding water when your grandchildren inherit that land. The story of Tarapa reveals a pattern we see repeated across agriculture. Indigenous knowledge that worked for millennia, erased through colonization, rediscovered by scientists, then suppressed by industries threatened by its implications. The technique is not complicated: fire, charcoal, organic matter, time. But teaching it would undermine the entire synthetic fertilizer model. An industry built on annual dependence cannot accommodate a solution that lasts centuries. So they do not teach it. Agricultural schools train students in NPK ratios, controlled release formulations, and precision application technology. They do not mention that indigenous Amazonians solved soil fertility 7,000 years ago using charcoal and fish bones. Extension agents funded by fertilizer companies do not demonstrate biochar production at field days, and farmers who have never heard of something cannot use it. The information exists, published in scientific journals, documented by archaeologists, validated by field trials across 6 continents. You can dig a pit today and start making biochar from yard waste. Crush it, activate it, and apply it to your garden. And it will still be improving your soil when your grandchildren inherit that land. That is what terrifies the fertilizer industry. Not that biochar might work, that it works too well to be controlled. They cannot patent charcoal. They cannot monopolize a technique that humans invented 7,000 years ago. They cannot force annual purchases of something that lasts for centuries. So they chose silence. But silence only works when people do not know to ask questions. Now you know. The black earth is real. The science is solid. The method is simple, and it is waiting in your backyard, buried under agricultural dogma and corporate interests that profit from keeping you dependent. The choice is yours. Keep buying fertilizer every year or spend a weekend learning what indigenous Amazonians knew millennia ago. The soil does not forget. Tarapa sites in the Amazon are still producing food after 2,000 years. Your garden could do the same.